Okay, here we are in video 21-1B, and we're starting to use the idea of set theory that we just encountered in the last video to start calculating probability. So you guys, a probability experiment is defined here as an activity that involves chance. So what is the chance that some particular outcome is going to happen? Each repetition of the experiment is called a trial, and each possible result of the experiment is called an outcome. When you have a set of outcomes, that's known as an event, okay? So all the possible ways something could happen. And the set of all possible outcomes is called the sample space. So a probability measures how likely an event is to occur, and we simply take a ratio or a fraction, okay, that the probability of an event A occurring is the number of outcomes in that particular event divided by the total number of outcomes or the number in the sample space. And we've been working with this idea of the number of what we want out of the total for a while, even with geometric probability, as you saw there with your shaded areas. But now we're going to use set notation to talk about it. And so it is going to be the number of items in the set A, which is the likeliness of that event occurring, and then the divided by the total number of outcomes in the sample space. So let's go and do some examples, and I think this will fall into place for us. Let's go to the next page. So we're starting here in example 1 on page 1086 by just simply rolling a number cube, okay? And we are told that event A is what happens when we're rolling a prime number on a number cube or a die, and event B is rolling an even number. So our total S is our sample space, is all the different possible outcomes we could get when we roll the die. That makes sense. 6 different sides on the cube, so 1, 2, 3, 4, 5, or 6 are our possibilities. So the total number of items in set S is 6. Now, if we have A is if we land on a 2, 3, or 5. That's prime. So the number of items in the set A is 3. And so the probability of rolling a prime number is 3 possible outcomes in set A divided by the total number of outcomes, which is 6, or 1/2 when we reduce that fraction, when we simplify that fraction. So that takes care of the first probability. The next one we want is A union B, as you can see here. A union B is all of the prime numbers in A and also all the even numbers that are not yet used. So there's 2, 3, and 5, and we also need to include 4 and 6. So the union of those two sets has 5 items in it, and so the probability of the union of those two events means either rolling a prime number or getting an even number, is how we would say that in words. We would say is 5 items out of the total 6, or 5/6. Now if we need to, we can make a little Venn diagram, as you can see up here as they've done for you. So here's my prime numbers in A, 2, 3, and 5, and here's my even numbers 2, 4, and 6 in B, and just like before we have an overlap here where 2 is used in both sets. So in my A intersect B, which is my next probability in this list they want me to calculate right here, is just the one element, the number 2. So the number of elements in the intersection of A and B is just one outcome. And so the probability of getting that outcome, of rolling just a prime number and an even number, since there's only one of those, is 1/6. And then finally, what's the probability of a complement, which is not rolling a prime number, would be take what are the non-prime numbers, 1, 4, and 6. So the number of items in the complement of A is 3, and therefore the probability of the complement of A, or of not rolling a prime number, is also 1/2. Let's look at part B and see if we can reason through these as well. This time we have a grocery basket and we have one of each of the following items: oranges, green apples, green grapes, green broccoli, white cauliflower, orange carrots, and green spinach. It says we're getting ready to transfer our items to the cart, to the conveyor belt, and we are basically choosing an item at random. So S, of course, is the list of all the different possible fruits and vegetables that we have in our cart, and there are 7 of them. So the number in that sample space total is 7. Probability A, remember, is choosing a vegetable first. So the vegetables out of this sample space are broccoli, cauliflower, they've started the list for you, but we also have carrot, and we have spinach. And so the number of items in that set is, of course, 4. So this is how the notation would work here. The probability of event A, or the probability of me picking a vegetable first, is the number of items in set A out of the number of items in my sample space. And I've just calculated both of those to be 4 and 7, so 4/7 is my probability. A union B is what if I picked a vegetable or a green food. So that would be the items are broccoli, an apple, cauliflower, a carrot, spinach, or a grape. Remember, those are all the items that are either a vegetable or are green. And so the number of items in that set there, A union B, is 6 different items. So again, the notation is the probability of the union is the number of items in the union set of A and B, which we know to be 6, out of the number of items in our total sample space, which is 7. So 6/7 is the probability there. Then we're going to look at A intersect B. As you can see here, A intersect B, remember, is the overlap between those two. So if I was giving these words, A union B would be green or a vegetable, and A intersect B would be only the ones that are both green and a vegetable. Well, the only green vegetables that we have in our list, you guys, are broccoli and spinach. So that's 2 items in the number in that sample space, and therefore the probability is also calculated by taking the number of items in the intersect sample, which is 2, divided by the number of items total, which is 7. So we have 2/7. And then finally, one last probability to calculate, and that is the probability of the complement of A, as you can see at the top there, that we need the number of items in the complement of A. So again, if this is A, the number of items in the complement of A are the 3 that are not in this list out of my 7. So that's 3/7. Okay, let's see what we can do with your turns on the next page. Page 1087. I would like you guys to do here on the your turns numbers 3, 4, 5, and 6, and it's walking you through the same 4 relationships among your sets. A union B, A intersect B, and then A complement, all 4 of those probabilities, reading through carefully the your turn problem. Okay? We'll see you guys next time.